This section is on the rectangular coordinate system. More specifically, we'll be talking about how to plot ordered pairs and find ordered pairs that satisfy a given equation. To begin, let's review. An ordered pair is a pair of numbers written within parentheses. It consists of an x-coordinate and a y-coordinate. You would write this ordered pair with a parenthesis, the x-coordinate, comma, the y-coordinate, and another parenthesis. The graph at the right is where we can graph an ordered pair. The origin is where the two lines intersect. We can label this point O. To place or plot an ordered pair on the graph, we move x units from O to the right or left along the x-axis, and then y units up or down parallel to the y-axis. To practice, we can plot a few points. The first is -3, 2. The 3 is a negative number, so from O we're going to move 3 units to the left. 2 is a positive number, so we are going to move 2 units up. This point is -3, 2. The next is -3, -1. Again, 3 is a negative number, so from O, we move 3 units to the left. 1 is a negative number, -1, so we move 1 unit down. This we can label -3, -1. For the next example, we have 2, 4. Both of these coordinates are positive, so from O we move 2 units to the right first, and then 4 units up along the y-axis. This point is 2, 4. And lastly, we have 2, -2. The x-coordinate is positive, so from O we move 2 units to the right. The -2 is negative, so we move 2 units down. And we can label this 2, -2. Now let's talk about how to find ordered pairs that satisfy a given equation. Each solution for an equation with 2 variables includes 2 numbers, one for each variable. We write the solutions as ordered pairs. A solution to a given equation is simply the ordered pair that, when it's plugged in, makes the equation true. So for example, if we're given that 3, 1 is a solution to x plus 2y equals 5, to show it's a solution, we plug in 3 for every x and 1 for the y. To begin, we start with the equation. We plug 3 in for the x and 1 in for the y. When simplified, we have 3 plus 2 equals 5, and 5 does equal 5. This statement is true. To show 2, 3 is not a solution to the equation, we show the final statement is false. To begin, again, we start with the equation x plus 2y equals 5. We plug in the x-coordinate, which is 2, and the y-coordinate, which is 3. 2 plus 6 equals 5, but 8 does not equal 5, therefore the statement is false, and the solution 2, 3 is not a solution for this equation. If we are not given the solution to an equation, we can find it by choosing one value for either the x or the y, and then substituting that value into the equation to solve for the remaining variable. Let's do an example. We are asked to find the solution to 4x minus 5y equals 20. Although you can let any number equal x, we're going to let x equal to 0. The first step we want to do is plug in 0 for x into the equation and then solve for y. So it's 4 times 0 minus 5y equals 20. We simplify and we get negative 5y equals 20. We then need to divide both sides by a negative 5. When doing that, we're left with negative y equals 4. To get rid of the negative 1 in front of the y, we again need to divide both sides by a negative 1 this time. And what's left is y equals negative 4. Since we started with x equals 0 and we solved that y equals negative 4, we write the solution as the ordered pair 0, negative 4. Other linear equations, similar to this example, have an infinite number of solutions. For every real number we select for one variable, there is a real number for the other variable. To graph an equation, we connect the set of points that correspond to all ordered pairs that satisfy the given equation. If all the ordered pairs that satisfied the given equation were graphed, they would create a straight line. The equations that we've seen so far are called linear equations in two variables. A linear equation is an equation that is in the form ax plus by equals c, where x and y are two variables and a, b, and c are real numbers. This form is also called the standard form.